Hey, how you all you wonderful students doing out there? Brother DeVoe coming back with you for another video, real quick from the Blue Dungeon. Today we're going into Unit 7, Concept 7, talking about factoring out the greatest common factor, also just known as GCF. Try to make it a little bit quicker today. The goal is to keep it under 10 minutes, but there is a lot to cover. So why don't you hit pause right now. Go ahead and take out your packets, whether you're printing them out or bringing them up digitally on another laptop. Do that now so we can go ahead and get this started. Alright, so you'll see in the packet it starts with a discover question where we ask you to distribute. Something we've done a while before and you guys are pretty good with that. And then we want to do something, we say undistribute, which is really not a mathematical word, so we really say it's factor, but we want you to associate factoring with undistributing, taking it backwards. So why don't we take a quick pause, hit pause, and go ahead and distribute 4 times x minus 2, and then factor or undistribute 4x minus 8. Alright, once you've done that on your own, let's go ahead and do it together. So we talked about distributing a long time ago. We said whatever number is outside the parenthesis, you have to multiply it with each term inside the parentheses. So in this case we get 4 times x, which is 4x. And then 4 times this minus 2 or negative 2, which will give us minus 8. And that's it. That would be distributing 4 into the x minus 2. You'll see how we did to discover, Miss Murdoch and I, you see how we hooked that up. Then now we said undistribute 4x minus 8. So probably you already know the answer, as you said, oh wait, there's 4x minus 8. When you undistribute, if we go backwards or factor, 4x minus 8 can be written as 4 times x minus 2. This is very similar to way back in elementary school when you learned multiplication and then division, being inverse operations of each other. When you learned 4 multiplied by 3 gives you 12, then you also learn, well, 12 divided by 3 gives you 4. Or 12 divided by 4 gives you 3. So whenever you can multiply or do one operation in mathematics, there's always a way to undo it, or inverse operation. In this case, we say factoring. Alright, so we noticed something real quick. There was a question on there that I wanted to talk about where it asked you, why can we not factor or undistribute a 4 in 4x plus 6? So here we took a 4 out, but then in part B you'll notice they did not take a 4 out. Why don't you hit pause real quick and see what your reasoning is of why do you think we cannot undistribute a 4 in part B where it says 4x plus 6. Alright, so once you had a chance to do that on the Ed puzzle, and let's take a look at this. We've talked about greatest common factor, right? And we talked about factoring numbers from a long time ago. But let's go back and look what we're talking about here. So we have two terms. We have this 4x and we have this minus 8. When we look for greatest common factors, if you're looking for factors of 4, you're looking for what numbers can you multiply to get 4. Right? So if I want to multiply to get 4, maybe I do 1 times 4. That would give me 4. Or maybe 2 times 2. That also gives me 4. And then when I want to go ahead and find the factors of 8, I know we can do 1 times 8. You know, you always have at least 2 factors with any number, 1 in itself. But then I also can write 8 as 2 times 4. 2 times 4 is 8. So when you start looking at the common factors, you're looking for what do they have in common. Well, I see they both have a 2 in common. 2 goes in the 4 and 2 goes in the 8. But then I also notice, well, I see this green mark is not showing up real well. So let's There we go, that's better. But I also notice they have a 4 in common. 4 goes into 4. Every number goes into itself. Then 4 also goes into 8. Do they have any other numbers in common? Oh, how could I forget 1? They have a 1 in common as well. So these are their common factors. But when we talk about the greatest common factor, well, of all these factors, what's the largest one they have in common? And in this case, the greatest common factor is this 4. And because they both have a 4, right, because it's the common factor, even if we didn't see this distribute to begin with, we would know to come out and take this 4. 4 is the greatest common factor of 4x minus 8. And we're going to do some more examples of that. So your answer here, why can we not distribute? Why can we not undistribute a 4 here? Well, we already said it's going to be embarrassing when I scoot this chair over and I slide right out onto the floor. Y'all didn't see that, did you? When you go ahead here and we say 1 times 4 or 2 times 2, if we list the factors of 6, well, 1 times 6, you can always start with 1 in a number. And then 2 times 3, 2 times 3 gives us 6. When you look at what they have in common, okay, 2 goes into both. 2 goes into 4 and 2 goes into 6. 1 goes into both. 1 goes in every number. But there's no 4 over here for 6. 4 doesn't go into 6. Just as 3 doesn't go into 4. So when I look for the greatest common factor, the greatest thing they would have in common is a 2. And that's why in part B, you'll notice they only factored out the 2 and leaving you with 2x plus 3. Right, in this case, 2 was the greatest common factor between 4 and 6. Alright, so go ahead and finish that off. Get that in your notes there real quick. If you didn't get that before, go ahead and hit pause and put that on your packet. That the reason why we couldn't undistribute a 4 is because 4 does not go into 6. Unlike in this case, 4 did go into both, and 8. So, hit pause real quick, catch up on your notes, and then I'm going to get back on the packet with you for example 1 we'll do together. Alright, so let's check this out real quick. Oh my goodness, 8 minutes already? I'll have to go fast for these next few examples. But I hope you guys appreciate the examples and it's helping you out with your notes. So, sorry, looks like my writing got small there, but take a look on your packet. We're looking at example 1. It says factor 10x plus 15. So we showed you an example already factoring, but let's actually get some notes in there. Let's take some time to copy our notes to actually see how do we do this, right? If we don't see the original problem like before, how do we do it ourselves? And so the first thing for our steps to find and factor out a greatest common factor is actually find the greatest common factor. What is the greatest common factor? That's how you need to start. And so what you should do is look at each term, we talked about terms, and find out what numbers go into it, and then find the common one. So we actually wrote this out. Let me see if I can make it a little bigger here. We have a 10. And 10 can be written as 1 times 10. 10 could also be written as 2 times 5. And is that it for 10? Yeah, I think that's it. So let's go over and check out the 15. Well, 15 could be 1 times 15. You can always multiply by 1. What else can we multiply together to 15? Oh yeah, how about 3 times 5? Is that all the choices to get 15? I believe so. So now let's see what we have in common. It's got to be in common. What do they both have? Well, let's see. We've got a 1. They both have a 1. Do you have a 10? No 10 over here. How about a 2? No 2 over here. But I do see they both have a 5. Right? So when I look for the greatest of the common factors are 1 and 5, and the greatest of them is 5. And so that's how you want to start. Find the greatest common factor. In this case, if we're factoring 10x plus 15, the greatest common factor we said is 5. All right, well, we found the greatest common factor, Brother DeVoe. Where do we go from there? Next step, undistribute, divide out the greatest common factor. So let's divide each of these guys by 5. We'll put that in parentheses. So 10x divided by 5, well, 10 divided by 5 is 2. So that'd be 2x. Plus 15 divided by 5 is 3. All right. So we did our little division. And then it says write the GCF outside the parentheses. And so whatever our greatest common factor is, 5, we'll put it outside the parentheses. And there you go. Congratulations. You just factored using the greatest common factor. All right. So go ahead, let me get that in your notes. And why don't you try examples 2 and 3 on your own, real quick on Edpuzzle, and then I'll come back and do another example for you. We'll do example 4 together. All right. So we got a nice little tip for you. So why did we choose example 4? What's different about example 4? Yeah, you got it. We have this leading coefficient has a negative here. So I have another hint I want you to put down in your notes right now. If the leading coefficient is negative, we factor out a negative. All right? So if the leading coefficient, leading being who's first, so if that first number has a negative, we're going to factor out a negative. So 8 and 4, I think we already looked at that before, right? We said the greatest common factor, 8 and 4, we already said that was 4. For time's sake, we're just going to already jump and say that the greatest common factor in between 8 and 4 is 4. You can go ahead and look back in your notes and see how we got the greatest common factor between 8 and 4 to be 4. But this time, because the leading coefficient is negative, we're going to make it a negative 4. And then once you make it a negative 4, go back into your steps. We found the greatest common factor is negative 4. Step 2, undistribute or divide out the GCF. Keep that undistribute in quotes. Don't go around letting people know that our Brother DeVoe used the word undistribute, because that's not really a real word. But we work it, well, not a real mathematical term, I'll say. All right, so let's divide each of these guys by the greatest common factor. Let me rewrite it over here. 8x squared plus 4. We're going to divide by the greatest common factor, which we said was negative 4. We do that to get the leading coefficient positive, because a negative 8x squared divided by negative 4, that's going to give me a positive 2x squared. And then positive 4 divided by negative 4, be careful, positive divided by negative is negative. This would be a negative 1. And step 3 says write the GCF outside the parentheses. What was our GCF? It was negative 4. Let's put that outside the parentheses. And we can always multiply that back together to see, oh, negative 4 times 2x squared, that is negative 8x squared. And negative 4 times negative 1 is positive 4. So you can check that. Sorry, going quick now. I don't know how the time is flying. Yeah. Maybe I could get one more in real quick to help you out with your notes. And then we'll let you do the rest on your own. Alright, so this packet was a little bit long, but it's a lot of things about greatest common factors. So we really want to make sure you have an example on all the different ways it happens. Alright, so we started with the greatest common factor. We did it when we had a negative out front. Now we had a couple of other examples going through here. As I look through the packet, we see there they had a situation where they had 2x to the third plus 20x squared plus 18x. Now what's different about that? Well, we can see that each of them now have an x. We didn't have that situation before where all the terms had the variable. So add this to your notes, hit pause real quick. We always want to factor out, undistribute the GCF. If it is possible to factor out a variable, then we must. So that's important. Hit pause real quick and get that down. If there's a variable, we must factor that out. Alright, so what does that look like? Let's go back to our rules. Our rule says first we want to find the greatest common factor. In this case, we'll check the numbers. For time's sake, go ahead and do it on your own and give it a quick try. What goes 2, 20, and 18? Well, the greatest number would be 2. Can't be bigger than 2. So 2 is going to be part of our greatest common factor. And they all have an x. So in this case, our greatest common factor is 2x. Right? So now that we know the greatest common factor is 2x, because everyone has an x, go ahead and divide everybody by 2x. Sorry, hopefully your notes are needed in Brother DeVos. That's a 2x there. Let's see what that happens. 2 divided by 2 is just 1. Now x to the third, when we divide variables, think back real quick. What was our rule when we were dividing variables? You got a good memory. Good job there. We subtract the exponents. So x to the third divided by x to the first is x squared. Divide the coefficients. 20 divided by 2. 20 divided by 2 is 10. You knew that way before you met Brother DeVoe. X squared divided by x to the first. We're going to subtract the exponents when dividing. 2 minus 1 is going to be an x to the first. And if it's x to the first, we talked about that before, you do not have to write it. Same about the 1 as the coefficient. You do not have to write the 1. But it's not wrong, so I'm going to leave it there. 18 divided by 2 is going to be 9. Now we have x to the first divided by x to the first. Now, keep that in mind. Anything divided by itself is just 1. So that's x to the first divided by x to the first. It's kind of an x to the 0, which we said x to the 0 is 1. Let's put a lot of other stuff in there, all review things here. But just to remind you, x to the 0 power is 1. And so if you wanted to put the 1 instead of there, but now things are looking a little bit too messy. Let's clean this up. 1x squared, let's just make that x squared, plus 10x to the first power. Let's just say 10x. 9, it was x to the 0 power, which is 1, but 9 times 1 is just 9. So we don't need all those extra ones floating around. We'll stop right here. And then as we're approaching the 20-minute mark, I'm going to give one more example for you. When factoring, if all the terms have the same variable, just use the lowest exponent. Just giving you one last tip. Hit pause. Go ahead and write that tip in there. When factoring, if all terms have the same variable, use the lowest exponent. Just a little quick hint. Even if you think about it here, they all had the same variable x. This was x to the third power, x to the second power, x to the first power. Who did we use? We used the lowest exponent, x to the first power. So in this case right here, let's see if I can get it done in 1 minute. To find the greatest common factor, we said use the lowest exponent. So it's a b to the fifth and b squared. They all have the same variable. The lowest exponent would be to the second power, b squared. 12 and 8. If you go ahead and work it out on your own, you'll see that the greatest common factor they have is 4. 4 goes into 12 3 times, 4 goes in 8 twice. So real quick, 30 seconds, Brother DeVoe. Let's keep this at 20 minutes. Let's divide by the greatest common factor. 12b to the fifth. 12 divided by 4 is 3. Subtract the exponents. That's going to be b to the third minus, oh my goodness, I forgot to put the GCF in the last step. I'll go back and fix that. B squared over b squared. 2 minus 2 is just x to the 0, which is a 1. We'll stop there. Forgot the last step. Good thing I caught myself before we end the video. The last step is put the GCF back in front. That gives us the 12b to the 5th times minus 8b squared. And man, you guys would have been tearing Brother DeVoe up tomorrow, as well as you should, if I let this go. We totally forgot. The very last step would be to put the greatest common factor back in front. So please do that. Clean that up there. And wish I had some white out. But go ahead and fix that real quick. That looks terrible. We got to rewrite that. Make sure you have the right answer. Put the greatest common factor out front. And that's always super important, that that greatest common factor is out front. All right. So with that said, very long video. It's going to be half the period tomorrow. Get some time at home. But we covered a lot of different ways of doing the greatest common factor. And so I hope it's useful for you. And I'll see you tomorrow.